Hey guys, this is your screencast on how to do the math problems on worksheet number 3 on potential energy and kinetic energy. The first 3 are just definitions, so I'm going to let you go ahead and just do those on your own, and we'll just start number 4. Number 4, calculate the gravitational potential energy of a 1,200 kilogram car at the top of a hill that is 42 meters high. Well, right off the bat, you know they want potential energy. Okay, and the formula for potential energy is mass times height times acceleration due to gravity, little g. And we have all those in these problems. Potential energy is equal to mass. Here's your mass, all right, times your height. Here's your height. And your acceleration due to gravity is a constant, which we learned is always 9.8. So that will always be g, no matter what. You just multiply those three numbers together, you're going to get 493,920 joules. And to put it into your answer key in significant digits, it's 490,000 joules. Number 5, a science student holds a 55-gram egg out of a window just before the student releases the egg. The egg has 8 joules of gravitational potential energy with respect to the ground. How high in meters is the student's arm above the ground? Be careful of units. How do we do word problems? What are they asking? How high? They're asking for the height. All right, we know it's a potential energy formula, which is mass times height times acceleration due to gravity. Okay, they give us potential energy. Potential energy is 8 joules. So that goes right here where the PE goes. All right, so we have 8 equals mass. Mass is 55 grams. We change that to kilograms, 0.055 kilograms, times your height, which we don't know, all right, times your acceleration due to gravity, which is always 9.8. So we got to get height by itself. How do we do that? We divide both sides by 0.055 and 0.98. So we have 8 divided by 0.055 times 0.9.8. Do this calculation first on the bottom, and then it's 8 divided by that number. That will get you 14.84 meters, and significant digits is 15 meters. Number 6. A diver has 3,400 joules of gravitational potential energy after climbing up into a diving platform that is 6 meters above the water. What is the diver's mass? This is the same type problem as number 5, but instead of finding height, we are finding mass. All right, they want to know mass. It is still a potential energy problem. So potential energy is equal to mass times height times acceleration due to gravity. Our potential energy is 3,400. All right, so potential energy equals mass, which we don't know, times height, 6.0, times acceleration due to gravity, 9.8. So we have to get m by itself. How do we do that? We divide both sides by 6 and 9.8, which is what we've done right here. All right, multiply those two numbers together first. Then it's 3,400 divided by these two numbers multiplied together. That will get you 57.82 kilograms. Significant digits, 58 kilograms. Number 7. Calculate the kinetic energy in joules of a 1,500 kilogram car that is moving at a speed of 55 miles per hour, or 24.6 meters per second. Same thing. All right, this is a kinetic energy problem. What do they want? Kinetic energy. Calculate kinetic energy. The formula for kinetic energy is 1/2 times the mass times velocity squared. That's 1/2 mv squared. All right, so we got 1/2 times mass, which is 1,500, times our velocity, we're going to use meters per second, squared. Square your velocity, multiply it by 1,500, multiply it by 0.5 or divide it by 2, either one, and you'll get kinetic energy is equal to 453,870 joules. Significant digits, 450,000 joules. Number 8. A 35 kilogram child has 190 joules of kinetic energy after he sleds down a hill. What is the child's speed at the bottom of the hill? They want speed, okay? This is the same thing as velocity. How do we know we have to use that formula? Because it's kinetic energy. Kinetic energy is equal to 1/2 mv squared. All right, this is a little tricky. So they give us kinetic energy, which is 190. So it's 190 is equal to 1/2, right, times our mass, 35. All right, and we need to find out V. So the only thing left over in our formula is velocity squared. We're going to have to get rid of that square pretty soon, and we will. All right, so we want to get v squared by itself. So how do we get rid of 1/2? You can divide by 1/2 or you can multiply by 2. All right, so I multiplied by 2. If you multiply by 2 to both sides times 2, this cancels out with the 2 on the bottom, and we're done. If you multiply by 2 over here, then you got to multiply by 2 right here. So it's 190 times 2 divided by 35. That gets v squared by itself. Okay. Once you do this calculation, okay, you have to take the square root of both sides. That's how you get rid of that square. Okay. So this number here is going to be 10 point something. Okay. When you take the square root of it, you're going to get v is equal to 3.29 meters per second, or v is equal to significant digits 3.3 meters per second. Number 9. Calculate the gravitational potential energy of 93 kilogram skydiver who was 555 meters above the ground. This is a straight multiplication problem all the way across. Just fill it in. Potential energy, mass, all right, times height times acceleration due to gravity. Just plug them in. Mass, 93. Height, 555. Acceleration due to gravity, always 9.8. Multiply all three together, and you get potential energy as 505,827 joules. Significant digits, 506,000 joules. Number 10, straight problem, easy. What is the kinetic energy? All right, kinetic energy is 1/2 mv squared. All we gotta do is just plug them in. All right, 1/2 times our mass, it's a 0.2 kilogram bullet. There's our mass, 300 meters per second. There's our velocity, and we square it. All right, so square your velocity, so it's going to be like 90,000 times 0.02 divided by 2. When you do this calculation, you're going to get kinetic energy is 900 joules, and that is already in significant digits. All right, so that is how to do the math problems for worksheet number 3, potential energy, kinetic energy. See you guys.